sketch
The
this
red
out?
box is there.
All right, good.
Okay, sketch the system of inequality given these two. First, you absolutely need to know the point of intersection. Okay? You want to work with the equations first, because those are the easy ones to work with. So we have these two systems, and you want to find the point of intersection. Now, there are many ways to find this, and actually I know at least 3, but that's for another discussion. So whatever you use, if you can find the intersection, that's good. Okay? For now, I will use the substitution because y is already solved for 3x minus 1. So I'm going to say that since y is 3x minus 1, I'm going to replace this y by 3x minus 1. So what do we get? We get x plus twice of 3x minus 1 equals to 5. And that gives you x plus 6x minus 2 equals to 5. And that's 7x equals to 7, so that gives you x equal to 1. Right. And then once you have x equal to 1, plug that back into y, so that y is 3 times 1 minus 1. So what's y?
2.
3 times 1 minus 1 equals to 2. So that tells us that 1, 2 is the point of intersection. Now second, I need to draw these two graphs. This one's kind of easy, right? You have, well, okay. You can use slopes and also y-intercept to draw this. But let's try to just use 2 points. Okay, so let's see, 1, 2. Where's that? Let's say 1 and then 1, 2. 1, 2 is here. That's the point on both of these lines. And since 2 points determine a line, that means I just need one more. So if I plug in 0, what do I get? Negative 1. So at 0, I get negative 1. So therefore, I have this as my first line. Okay, so this line corresponds to this, because I just plotted 0, negative 1 at this point. Now for this,
you set x to 0, so it's y.
yeah, I just
okay.
plugged in x equal to 0, and I got y equals negative 1. Now for the second one, let's see, if I plug in y equal to 0, what do I get? X equal to 5. Yeah. I thought about plugging x equal to 0, but then that gives me y as some integer, a fraction. I don't like it, so I just thought, okay, I'll just set y as 0. If I do that, I get x equal to 5. So that means when x is 5, 1, 2, 3, 4, 5, I get y equal to 0. So this second equation will be passing through this point and also point of intersection. So that's what I have. Once you have drawn the lines needed, now we have to determine what's the actual domain that satisfies the inequality. Right? All right. Now I put both as equal or less than, right? In this case, the boundaries happen to be part of the solution, right? If I had any one of these as strict inequality, then the corresponding line should be dotted lines. Yeah. Yes?
So with the first equation, we obviously picked 0. How come you picked 5 for the second, again, second inequality?
You just pick anything. You can plug in 1 if you want. If you want to plug in 1, that's fine. Well, if you plug in x equal to 1, then you're going to get y equals to 2. So 1, 2, that's the point that we already know. Just my idea is just find another set of solutions that will satisfy this, because it's a line equation. A pair of solutions gives you a point on the line, and if you have 2 points, then there's a unique line passing through.
X was 5. What was y in the second inequality?
I plugged in y equal to 0.
0, okay.
Yeah, and then I got x equal to 5, right?
So y is 2 and x is 1, right?
Y is to x equal to 1 is the intersection of 2 points. It's a point that's on both of the lines. That's what I got, right? Okay. After that, I just found individually 2 other points, that one belonging in here, one belonging in there. So that's how I drew this graph. Okay? Yes?
So we plug in part of the equation, the find the intersection, and then we set y to 0 to find the y-intercept, the x-intercept, and then we set x to 0 to find the y-intercept.
You don't always have to do that.
Yeah,
All
but
I'm
that's just
saying
how we
is
did
the
it,
following.
yeah.
Yeah.
No, that's good.
What we want to do is first find the intersection. Next, find one point for each of the lines so that you can draw the graph. You can do that, right?
Yes.
That's really basic, right? Plug in some number, get some other number, and you get a point on the plan, and you can draw the graph. That's easy. Okay. Now, the next thing that you want to do is for each one of these, I want to know which part actually solves this inequality. Right? And to do that, you use test points. And as long as your line doesn't pass through 0, 0, then you can always use 0, 0 to be your test point. And I find that to be the easiest one to use. Now, if it does pass through the origin, then 0, 0 will be on the boundary, and that's not good. In that case, you have to find some other point. Okay, I'll try to do another example when there's more time. Okay, all right. But let's just assume that none of them passes right through 0, 0. In that case, we'll just plug in 0, 0. Okay. So first equation, at 0, 0, you plug in 0, 3 times 0 minus 1, and you get 0 less or equals to negative 1. Now, does this mean 0, 0 satisfies the inequality or does not satisfy the inequality?
Does not.
Does not, because 0 is greater than negative 1, so this is false, right? Since this is false, and we were playing with this one. Remember, this is y equals to 3x minus 1. We're playing with this one. Since this doesn't work, which domain is the right one that satisfies this?
Below it, to the right of it.
To the right of it, this one, right? Okay? So that part must be the solution to the first inequality, because this 0, 0 didn't work. Okay? Now let's try the same thing for the other equation at 0, 0. Let's plug in 0 here, 0 here. What do you get? We get 0 plus 2 times 0 less or equal to 5. So 0 is less or equal to 5. What does that mean? It works or it does not work?
It works.
It works, okay? If it works, then we can say that for this one, the region containing the 0 is the one that works, okay? See, lines divide the planes into two halves, and depending on whether your 0, 0 works or not, you can determine which half actually makes this, satisfies the inequality. Got it? Okay. Now that we have this one and this one, what's the overlap of both?
The bottom quadrant. Bottom quadrant.
Yeah, this part, right? So that's the final answer. Now this is a little messy, so let me try to draw that again. So what is the final answer here? So here's 1, here's 2, and there's negative 1 here, so you get this. And there's a 5 here, so you get another line here. And the solution of that system is here. And we should delete these because that's not part of the solution. Right? Yeah. It's only these boundaries, and containing this region in between. Okay? That's how you solve a system of inequalities.